Okay, so I'll just keep talking about it and not worry about repeating or organized, just because I want to, the more you get exposed, the more you absorb by osmosis. So there's, I was going to go through the whole API. So we were talking about disk blocks. So the thing you have to know is there's partitions and there's block devices and there's drives. A block device is for example, a hard disk. A partition, you can have multiple partitions on one hard disk. So there's drive. Drive is synonymous with partition. Maybe I should get rid of the duplicate. Partition is usually when it's away from the customer or the user. Anyway, drives are identified by a letter. How about I do this? Guess what this is going to do? Bow. Let me explain. So, class rep, the structures, the class structures that the compiler owns are retained. All that information is kept on all the classes, and it can be used to dump a record. It will fetch the information the compiler has and dump the record. This is an interesting kludge, not a kludge, I don't know what you want to call it. This helps it, this tells the class name of the previous parameter. This has the class name of the previous parameter. So, in other words, I think it's the same as if we say this. It's identical. It can figure that out. So this is a partition structure. 3F, if you know anything about drives, you know there's a gap at the beginning. Root cluster 2. Now my Red C file system, there's sectors per cluster. I set it equal to 1. I want it as simple as possible. I like it. I like getting rid of concepts. Like, I don't have physical and virtual memory. I have memory. I don't have different files. I don't have virtual file system. I just have file system. I don't want clusters. I just want blocks. But you have to have clusters if you go relative to the start. I could get bold and go absolute. I'd have to think about that. Absolute block instead of relative to the partition. Anyway, so maybe I should do that. I could do some work. Anyway, so there's we could anyway. So what do we want to talk about? You can read a block. U8 buffer 512. Read block. You can do a database. It would be fast, but the only problem is that we don't support fast I/O. Partition buffer block count. Partition buffer block. I think it has to be within the partition. Let's say 0x3f. Partition buffer block count. Then we say dump buffer count 512. Okay, so this is the boot. This is the first block of the partition. Wow, it doesn't have. It doesn't look like it has. It's bootable, but it is bootable. What the? Maybe I'm confused. Is that? Oh, that's the boot code. Okay, never mind. That's the boot code. I have very simple boot loaders. I think that's a boot. We can unassemble. You want to do that? Let's unassemble. Okay, so technically this is C boot structure code. C boot structure buffer. I call it boot record. Address boot record. Address boot record. If it crashes, we typically hard crash. Okay, so now let's unassemble address or boot record code, boot record.code. And we give it number of instructions, let's say 20, and then we say if it's real mode, 16-bit unassembly is not well supported. Okay, that does not look good. What's the upper? So we can dump memory if we say DM. Now we have addresses. What is this, 680? So we are not looking at the correct thing by a long shot. Okay, so this is not what we want. That's for... We most definitely have a I don't know what the hell's going on. What's the offset of code? Son of a bitch. Let's do this. Class rep address BR. Okay, that's definitely a no-op signature. 4D. I don't know what that is. Reserved sectors. Oh, that doesn't look good. Root cluster. This is probably FAT32. No, what? Code. Let's go to what it jumps to. 58. 58 plus... Is it the beginning or the end? I forget. It's the end. 58 plus 3. How about dump U8 pointer 50B. That doesn't look good. What the? That's not good either. Why isn't there a boot record? And why is the... Why is sectors messed up? This looks like, this is not it. That's the long story short, this is not it. Is this relative to the offset? Last rep. Boot record. Exception partition. I don't think we were looking in the right place. Boot record. P offset. This is it's in memory. Let's go ahead and that's on the stack. 5.8 plus what's 5.8? A8 BO. Wait a minute. No. What? 5.8 BO. It's right around here. Maybe. Okay. Yeah, there's a 66. That's definitely an instruction. Okay. So what the fuck is my problem? Read, boot record, dump, boot record, class rep. It's the wrong structure. What is this structure? What's the signature in this? Signature. Oh, it's correct there. Look at that. Code. I don't know. Oh well. What? Let's dump some more code. Let's dump 50 lines. Okay. Oh, that's the DAP. The record for interrupt. We use interrupt. Okay, we just didn't have enough. So we use interrupt 13, which is interrupt 13 number 42 is the BIOS for loading, and there's a structure, a DAP. That's what that is right there. I don't know why the offset from this is where it starts right here. B3. Let's see if that agrees with B3. So if we take this, if we take 0x, that plus 5.8 plus 2, I think we want 2, we get 94. That's not B3. What is going on? Oh well, I don't know what's going on.